Here are a few textbook questions that are asking us to find the equations of these lines. Now you'll notice that they're all straight lines, but they all have your x or your explanatory variable as something other than x, if you will. So because they're all straight lines, the secret in answering this question is to remember our formula for a straight line, or our equation, which is going to be y equals mx plus c. You remember that. Now, we're going to actually change this a tiny bit to suit this question. And we're going to change this to be the response variable equals m times the explanatory variable plus c, which is our y-intercept. So now let's have a look at our first example using this idea. If we have a look at this, we can see our response variable is y, and our explanatory variable is x squared. We get that from the variable on this horizontal axis. So now what we need to do is we need to find out m, which is the gradient, and we need to find out c, which is the y-intercept. Now we can see that the y-intercept here is 0. So the last thing we need to do is have a look at our gradient. And our gradient, remember, is rise over run. And in this case, this gradient is the rise is 14.7, because if I was to draw my triangle, remember that every straight line has triangles which can tell us what the gradient is. If I was going to draw my triangle, it would tell me that the height is 14.7 from the origin to this point here, and my run is 12.25, which is my origin across to here. So therefore my rise over my run is 14.7 divided by 12.25. And when I put that into the calculator, I get 1.2. And that means my equation for this straight line in the form of, remember, response variable equals gradient times explanatory variable plus c will be, my response variable is y, equals m, my gradient is 1.2, times my explanatory variable, x squared, plus c, which is plus 0. Or if I want to tidy that up a little bit, I could write y equals 1.2 x squared. And that's the equation of my first straight line. Now I'm going to do exactly the same thing with my second example, but I'll do it a little bit faster. Here we can see my response variable is y, and my explanatory variable is 1 over x, which I get from the label on this axis. My y-intercept is 0, and my gradient is rise over run, which is 0.25 over 2. The only reason I can use this exact point here is because I know it goes through the origin. So my rise is from 0 to 1/4, and my run is from 0 to 2. So my rise is 0.25, and my run is 2, and therefore my gradient is 1/8, or 0.125 if I put that into the calculator. So now what I'm going to do is substitute this back in to my green equation here. My response variable is y. My gradient is 1/8. My explanatory variable is 1 over x. And my y-intercept is 0. And if I want to tidy that up, I would get y equals 1 over 8x with plus 0. Now, generally in further maths, you wouldn't be expected to write this as a fraction, which means you could write y equals 0.125, I'll make that decimal point clear, times 1 over x, and that would be acceptable. For the last question, we're going to do exactly the same thing. We can see again, I have a line that goes through the origin, which means it goes through 0, 0. So therefore, my y-intercept equals 0, and my gradient is the rise from 0 to 6, and the run from 0 to 1, which means my gradient is 6 over 1, which equals 6. My response variable is y, and my explanatory variable is x cubed. So therefore, when I put it into this formula, I'm going to get y equals 6x cubed plus 0, and when I tidy that up, I get y equals 6x cubed. So this is how I can turn these straight line graphs and state the rule that connects my two variables for each of these cases. If you found this video helpful, please subscribe or like. Thanks.